As global temperatures rise and the human population expands, more of the planet is vulnerable to desertification, the permanent degradation of land that was once arable. While land degradation has occurred throughout history, the pace has accelerated, reaching 30 to 35 times the historical rate, according to the United Nations. More than 75% of Earth's land area is already degraded, according to the European Commission's World Atlas of Desertification, and more than 90% could become degraded by 2050. How does climate change affect desertification?
One of the primary ways is you increase the temperature of the atmosphere, and warmer temperatures draw more moisture out of the land and whatever trees and vegetation are there. In fact, that has a stronger effect on trees, for example, than even water availability. And so when you ramp up the temperature of the atmosphere and it sucks that much more moisture out of the land, then that's a cause. And then, of course, we have the drought factor. Climate change is causing far more severe and far longer droughts than have ever been recorded. And so that obviously is causing desertification. And then extreme weather events. So a warmer atmosphere absorbs that much more moisture, can hold it for that much longer, and then you'll have one huge torrential downpour. But then it takes that much longer for that much more moisture to come back out of the land and then recharge the atmosphere because it's that much hotter. So all these things happening simultaneously has a dramatic impact on desertification. And those statistics you give are shocking and worrisome as they should be. And then lop on top of that human development and human encroachment into wilderness areas where it's been the moniker since Earth Day started, the whole hug a tree, that one of the best things we could do for climate change is for mitigation is to plant massive amounts of trees, and instead we're losing them at shocking rates, both from runaway climate feedback loops and from human encroachment. What's happening in the Amazon, for example, of chopping down more than an acre of rainforest every second, mostly for beef production. That should not be happening. We should be doing the opposite and setting aside more wildlands and planting more trees, and instead human encroachment, which is another huge contributing factor to that.
When sea levels rise as rapidly as they have been, even a small increase can have devastating effects on coastal habitats farther inland. It can cause destructive erosion, wetland flooding, aquifer and agricultural soil contamination with salt, and lost habitat for fish, birds, and plants. How does climate change affect sea levels rise?
Climate change affects sea level rise in several ways, but the two biggest are the melting ice across the planet contributing to sea level rise, and then the second one is thermal expansion of the oceans. When water is warmer, it takes up more space physically. And the oceans, the last, I believe, 6 years in a row now, have set a record warm temperature every one of the last 6 years. But so what we see, like I mentioned Antarctica earlier, so if we have warmer atmosphere, that's contributing to surface melting, which in Greenland, that's been the big factor. We look at what happened to Greenland last summer, record massive, shocking amounts of melting, where leading scientists there are warning of, look, Greenland is on the way out. Like we're seeing irreversible melting, where the only thing keeping Greenland an ice sheet is because it's so high and there's so much ice there, but it's in the process of being lost. But you look at Antarctica, for example, then you have not just warmer atmospheric temperatures, but there, so much of the melting's happening from the warmer ocean, so it's coming from underneath. So you look at the Thwaites Glacier, which is sometimes referred to as the Doomsday Glacier, because it's holding back. It's basically on the land underneath the water, and that's what's keeping it in check. But as it's being melted from warmer oceans below, once it loses that point of contact on the land, it's going to basically stop being the plug that it is for the massive amount of ice behind it. That alone is going to be a massive and immediate contribution to sea level rise. Or if we look over at the western Antarctic ice shelf, the vast majority of that is It's already in the ocean and it's being held in check. And as that melts from below, you could see a relatively abrupt amount of that ice lost in an extremely short period of time. In the West Antarctic ice sheet, that's 8 feet right there, minimum, of sea level rise that we could see in a very, very short way. And this is why we see James Hansen was co-author of a study fairly recently that showed, based on paleoclimate models, we could see, in theory, a 10 feet sea level rise by 2050 if some of these things happen that I just mentioned, like the Western Antarctic ice sheet and continued melting apace in Greenland as we're seeing right now, that it is not out of the realm of possibility to see that abrupt of a level of sea level rise in that short amount of time.